we're here to talk about longevity, so maybe it's good just to say, like, what is aging, right? There's all these familiar things we know about aging. Our hair gets gray, our skin gets saggy, maybe our senses become dull. There's also things happening inside our body, that we're aware of, that, we have cardiovascular problems, the vascular circuit stiffens, we have plaque buildup in certain areas. This can lead to like heart failure, hypertension, things. There's neurological decline, Alzheimer's, just a loss in cognitive function due to shrinking the cortex and demyelination. Muscle loss, we can weak over time because we have decline in muscle fibers, the fast twitch cells and motor neurons. So all these things are kind of familiar to us because they're kind of at this macroscopic level. There's also more microscopic changes happening. So sometimes these are called hallmarks of aging. And these are really happening to DNA. So there's instability there where just due to toxins in the environment or just normal metabolism, things become unstable. Telomeres tend to short during cell replication, and at a certain point they become too short to keep doing that. Cells can go into a senescent state, which isn't good. It has a lot of downstream effects with stress signaling. There's also the epigenome, which is patterns of methylation on the genome, and those tend to happen at a reliable rate. So that's one kind of thing that happens with aging, which can change how histones and chromatin are organized. There's also this kind of dynamic process of managing proteins in the cell, which can be disrupted over time. So maybe the cleanup mechanisms get degraded as we age. There's also a lot of downstream things from that. Those are kind of the main cellular processes, but we kind of lose the ability to do nutrient sensing. Stem cells exhaust. There's kind of altered communication between cells. Once you start disrupting hormones and cell-to-cell communication, that can have a lot of downstream things. People sometimes call that inflammation. All right, so that's all the bad news. This is the stuff that's happened to us that we want to stop. The rest of the talk will be more positive about the interventions and kind of what we can do about that. We're scientists, and I'd say longevity is a very quantitative field, so it's important to figure out, how do we measure the aging process, There's a few different ideas here. Ultimately, the best measurement of longevity is just how many years do you live, right? But I don't think anyone here wants to try to figure that out for themselves. It's going to take too long, and you won't be around after that. So instead, what we often think about is not chronological age, which is the number of years you've lived, but maybe your biological age. So there's this idea that if you looked at someone's measurements of their body and you didn't know what age they were, you could try to guess what their age is, just based on what you see. And that's what we mean by biological age. And believe it or not, those can be different. Some people age at a different rate. They appear younger than they actually are, and you can measure this with a lot of different things. So there's a few different ways to do that. I'll just kind of outline a few of them. One is based on fitness. So there's things like grip strength. You can measure the force that you can apply with your hand, and that turns out to be a very strong indicator of mortality. So that's a good signal. Body composition, you can use a DEXA scan to measure your lean mass, your fat mass, your bone density, and that tells you a lot about mortality as well. There's a test called VO2 max where you put on a treadmill, you put a mask on, and you have to see kind of what your maximum rate of oxygen consumption is at peak activity. Very hard process, but very useful signal. There's also HRV, which is kind of the interval time and how it varies between heartbeats. Turns out that's a good marker of kind of how you respond to stress and your overall predictor of fitness. And that one you can measure, which is watch. So those are fitness measures. I'd say those are not so specific, but they are kind of a good sense of just level of health and if you should be worried about mortality. There's more specific things you can get from blood markers. So there's high reactive or high sensitivity C-reactive protein, which is a measure of inflammation in general. And there's the basic stuff like lipid panels and glucose and hormone levels, which you can measure, and all those things are indicative of changes in your body with aging. I think the very interesting thing about longevity measurements, though, is not these more traditional things like fitness and blood, but you can actually look at the epigenome and look at the patterns of methylation. And because that methylation changes at a rate that's predictable, you can then kind of infer some sort of biological age based on that. So there's this idea of epigenetic clocks, which people have done a lot of research doing that, and you can actually go out and buy these tests, so it's something that you can pull off the shelf. And because you can look at different parts of the genome, that actually tells you a lot about different parts of the body. So, there's an idea that if you look at certain genes that are related to the lungs, that will tell you something about the age of the lungs. And you might ask, well, how do we know that's true? Well, there's some studies that have looked at, smokers, for example, and if you look at, their lung health based on these markers, smokers tend to have a faster rate of aging than non-smokers, and it tends to be selective to smoking. So their brain might be, their chronological age, but their lungs are. You can also measure telomere length, so that's another test you can do, and that's just a marker of aging. It's one of those hallmarks as well. That one you can measure at different parts of the body. I don't think products are available for that yet, but in theory you could. And then there's like a whole wide world of more complex measurements, which I would just kind of group under like AI-based measurements. So you can get an MRI done, you can look at OCT of your retina, you can measure someone's voice like mine, and all those things have signatures of aging. They're not as obvious, it's harder to look at them as a human, individual human, and say what is happening with their age, but you can use AI, and if you have a big enough data set, you can detect some of the patterns in those data sets. So there's a lot of work being done on that, where you can build models that predict your brain age or predict your retinal age. All these things are kind of fun and emerging. So the good news is we have a lot of ways to measure, how we age in different parts of our body. So that's the first step to changing things. If we don't know what's happening, how can we change it? The next step is, well, what do we actually do? What are the interventions that can help us? I'd say there's a lot of exciting research here. There's also a lot of back and forth about what's useful and what's not. But I think we've got a few good candidates that people have found. So there's rapamycin. This is one that is an mTOR inhibitor, which is originally an immunosuppressant. Turns out this promotes autophagy and reduces protein synthesis. If you look at small animal models, yeast or host mice, reliably increases lifespan. Exciting stuff. Resveratrol is another one, which is a polyphenol found in grapes, red wine, berries, and stuff. So if you enjoy those, maybe there's some benefit there. That one tends to mimic some of the same mechanisms of caloric restriction. So it has some antioxidant and anti-inflammatory effects. That one also has good evidence in rodents, and also specifically for high-fat diets. I'd say it's not as strong as rapamycin though. There's also metformin, which is an anti-diabetic drug, which targets the AMPK receptor. And what this basically does is it moderates insulin sensitivity, and it was kind of just an accident that we found that, as a community, that people who were on metformin tended to live longer, and that was even within the diabetic group. So kind of this counterintuitive aspect that people with the disease are actually outliving the people who don't have the disease and aren't taking metformin. So there's a lot of interest there. Again, that one is hard to test. There's two others I think we can talk about, which is NAD boosting. So there's two drugs, NR and NN, that are widely sold for that. And in principle, they improve mitochondrial function, DNA repair, sirtuin activity, and in general, people find that it's good for metabolic health and longevity in rodents. You might notice a theme here that a lot of this is in rodents, and I think the reason is that it's hard to do these studies in humans. A lot of times we want to target aging very early in life, and we just don't have the time to see those things play out. But we can do these studies in rodents. We'll talk more about that later. The last one is senolytics, drugs that can remove those senescent cells. So if you recall that when telomeres get short enough, cells stop reproducing, and these kind of senescent cells hang around and do some damage. And the idea of senolytics is to remove those cells. And there's actually interesting products there that you can get. There's even some skincare that they found they can remove senescent cells in the skin. So pretty cool work going on there. These are all very targeted to those hallmarks of aging, but there's actually other findings we have that are, I would say, simpler to adopt, easier to adopt, and maybe things we're already doing, which is good news. So there's dietary change. You can restrict your diet in a couple different ways. One is to restrict it in calories. You can say, well, I'm going to eat 80% of the calories that I actually need. Turns out that reliably increases lifespan in rodents and many other species. This is one of the strongest findings in longevity. And you can do studies to show that this interacts with insulin, IGF-1, mTOR, and all these pathways that we know are important. So there's something interesting happening there. The other type of restriction you can do is not calories, but when you eat. So that's intermittent fasting. So in that case, it could be that you skip a day of eating and you eat in alternating days, or it could be that you only eat from a certain time window, maybe from like 8 a.m. to 11 a.m., and the rest of the day you're not eating. There's some evidence there that it might have similar effects to calorie restriction. I'd say there's less evidence there. So those are two kind of dietary interventions. And then there's kind of the chores, I like to call them. So it's your sleep, exercise, nutrition. Just are you getting enough sleep? I know we're all people at Caltech, so that might not be the first thing that we care about. I remember when I was here, it was like sleep, social life, and school. You pick two. I think that's probably still the case. But it turns out sleep is just the most high gain for low effort you can do to increase longevity. It's just study after study shows that mortality is tightly linked to how much sleep you get. And it's even like a U-shaped curve, so that getting more sleep is not necessarily better. There's kind of a minimum around 7 hours per night. So can't stress that enough. I think the evidence is pretty strong there. The other one is exercise, so just getting out of the house. It's kind of hard to believe that, some days we don't leave the house, but if you start measuring your steps with a watch, you might actually be surprised to discover, how little you do some days. And it turns out that very small amounts of activity every day done reliably do have a strong correlation with mortality in humans. And it's even lower than you might think. So it's like 5,000 steps a day is enough to have a significant effect. So it's really just leaving the house and going for a long walk, just pleasant anyway, I like to think. Then there's nutrition, there's just making sure you get adequate macronutrients and micronutrients. Nothing shocking there, but if you don't do that, how could you be healthy? The last one's kind of interesting, which is social connection, that there is evidence that not just like well-being, but also longevity are related to kind of whether or not you have a supportive social network. There's these blue zone studies, I think, that are kind of good examples of those with some caveats. So that's like kind of the chores. There's also kind of fun and wacky stuff, which I can just briefly go through. These are things you might see online, and I would say they're more in the experimental, unproven category. So there's, hyperbaric oxygen therapy. You get into this little chamber.
Hi friends, I'm going to.
And that's Brian. So in the chamber, you have 100% oxygen, and it's pressurized, and the idea is that this simulates stem cell production and reduces inflammation, all these things. I think it was mostly developed for like wound healing, so if like you've been in a fire and you've got kind of everywhere, that's what they use it for in hospitals. But some people have them at home now, some people go to clinics, so it's actually becoming pretty common. I think the evidence is still out there, to be decided, but people are doing it. There's also plasma exchange, which is, I think, maybe the most topic in longevity is, basically exchanging your personal plasma with someone who's younger, and kind of, generates these memes and jokes about blood boys and things like that, which are not entirely untrue, that people are doing this. So there's some, people doing it, whether it's actually meaningful, I think that's, to be decided, but it is interesting to see that it generates a lot of interest in longevity. So I think I'm personally interested to see it, but whether it's meaningful is another question. There's also all sorts of wacky stuff like with cold plunge, sauna, GLP-1 is a major topic right now, hormone replacement, stem cells, gene therapy. This is kind of like getting to the frontiers of longevity testing, and I think we'll talk about biohacking later, and it kind of fits into that. And the last thing is just reducing things, exposures that are negative, so if you can just cut out stress, sleeping, smoking, alcohol, air pollution, these are all things that just have measurable changes on longevity. So a lot of this stuff is stuff that we can normalize, and it's easy to forget that we're surrounded by it. You can do fun things like get a air quality monitor, and you might discover air quality is not as good as you think it is at home, for example. Yeah, so that's a little rundown. You know, we talked about, you know, what is aging, how do we measure it, you know, what can we, you know, do to improve it. And there's also levels of evidence. You know, so we talked about, you know, there's, you know, rodent studies, you can do in vitro studies. You know, these are all ways that you can kind of understand things in a very mechanistic, controlled way. But, you know, people aren't, you know, rodents. You know, there's a lot of differences physiologically, especially when it comes to living as long as we do. So it's important that we do human studies as well. Those have some caveats, you know, so, you know, most evidence is based on epidemiology, meaning you kind of just observe people run the course of their life and see what happens. There's great data, so UK Biobank did that, and they just published a paper yesterday where they had a sample size of, you know, 500,000. So you can make some really cool observations. The downside is that you really can't disentangle causation and correlation. There's also kind of interesting confounds, like, so I mentioned the blue zone studies where, you know, they look at people in, you know, places like mountainsides in Italy, and, you know, they're smoking and drinking and living to be 120, right? Some of that I think has substance to it. We've also discovered that, you know, there's like pension fraud happening where, you know, someone passes away and they don't want the checks to stop coming, so they maybe swap people in, for example. So there was an interesting study that actually proved that to some degree. So all that to say that, you know, even epidemiology has some limits. The gold standard really is, you know, randomized controlled trials. So you want to have multiple groups that are blinded as to what treatment they're getting. They should be randomized, balanced, and you know, we should have controls that are proper so that, you know, the effects are not due to longitudinal change or you know, environmental or you know, seasonal effects, all this stuff. Yeah, but I'd say, like, you know, there's also this question of, like, should we stop doing some research if, you know, or should we stop doing some of these interventions if we can't test them thoroughly? So I'd say longevity is kind of in favor of trying out things, being more exploratory. So we'll get to that next, I think, which is this phenomenon of kind of like self-experimentation. But first, I think it'd be interesting to talk about, you know, practice. So we've talked about, you know, the research and the science behind longevity and all these interventions. What's surprising is it's actually, you know, started to fit into the healthcare system more than you'd expect. So, you know, longevity kind of is this response, I would say, to the kind of traditional healthcare system where, you know, I don't know about you guys, but when you go to a hospital, you maybe get 5 minutes with your doctor. Maybe you get like a yearly physical to get your blood work done. But for the most part, you don't go to a hospital because you're, you know, moderately healthy and you want to be more healthy. It's mostly like you're sick, you're injured, you got cancer, you definitely want to go to the hospital for that reason, but they're not really addressing this need of just, you know, self-improvement and kind of incrementally being better, right? So I think, you know, there's a couple reasons why, but we're at Caltech, so I think I'd like to give an example of someone who's kind of recognized this early on and been a leader in that field. His name is Leroy Hood, and you know, he was Caltech faculty, you know, many years ago. He was in the Division of Biology. He built the first DNA and protein signature synthesizers. He later left Caltech and founded kind of the field of systems biology, and he came up with this model of medical care. So he's a very prolific guy, and he's still alive and lecturing. I heard him speak actually just a few months ago. And he came up with this idea of P4 medicine as a response to the traditional, you know, healthcare system, which is, you know, stuff that we kind of take it for granted today. There's predictive is one of the 4 Ps, meaning that we use biomarkers and measurements to kind of predict what is the outcome of this person's life later on. Preventative, meaning we start acting before things go wrong. You know, this is actually huge. You know, if you try to manage diabetes early, it's much easier than waiting to the last minute. Personalized, meaning that your therapies are not just general purpose, that, you know, they're kind of tuned to you and your specific needs. Seems obvious in retrospect. Participatory is another one, so that, you know, patients are part of the process, they're informed as to what they're doing. Maybe they're involved with kind of observing themselves and reporting things to doctors, so very different model from just kind of receiving orders from a physician. So I think, yeah, it's really great he laid that foundation. I would say, like, longevity has kind of rebranded a lot of this stuff, so there's some amount of kind of crosstalk there you have to go through. Yeah, and I think the other thing about, you know, talking about healthcare and longevity is that there's kind of 2 things we want to optimize. There's like lifespan, which is just how long we want to live, but We also care a lot about the quality of life during that time. So there's this idea of health span, which is different from lifespan. You can imagine maybe a plot of like quality of life over time. And for most people, it's kind of like flat at the top, and it kind of rolls off towards the end, maybe after age 65. And that represents a lot of loss of quality of life, also a lot of costs in the medical care system. So just insane numbers of dollars spent for the last few months of life. Ideally, maybe we don't want to extend that curve. What we want to do is actually make it a different shape. So we want, health span to be kind of a flat curve that right up until the last minute continues flat, and then maybe there's a cliff at the end. So that'd be the dream, So some people want to live forever. Some people are more focused on that goal of just making quality of life good until the end. So I think that's a good way of thinking of it. And to address this, one interesting thing that's come up is there's this whole field of concierge medicine. So, like I said, there's all these issues with hospitals, and in response, a lot of doctors have kind of spun off their own private businesses where they can see clients, and they give them a much more personal touch. They can do more interaction. It's almost like they're coaching them for their health, but they are, physicians are trained and knowledgeable. And a lot of this is getting rebranded as longevity clinics. So if you see those two, I think there's a lot of overlap there. And a lot of what they stress is those things, those interventions we talked about, which are more lifestyle, so like optimizing nutrition, sleep, fitness, stress, harm reduction. There's, these good kind of targeted therapeutics they do too, but I'd say they focus on getting those essentials done first. And I think like the outcome of that is that they kind of apply this more data-driven way of thinking about the problem, where instead of kind of reacting to things, there's more of this, loop where you can make a measurement, observe something that's, out of range for your body, or some trend that's going the wrong direction. You can try some interventions, and then in as real time as possible, see how those interventions are changing all that. And it's, kind of obvious. It's kind of what we do in like machine learning. But it's actually been very rarely applied to health. We usually get a yearly physical, which is a very infrequent thing. If we were doing it every 3 months or so, and we were kind of tracking our health every day, we might discover things about ourselves that are useful. That said, there's problems with this model too. It's not some golden solution. It's usually out of pocket, so it's a lot of rich people paying for this stuff and supporting it. It's not accessible to the general public. There's some people working on that and trying to make it more widely available, so I think that will change, and there'll be some ways to kind of make more commodities out of these treatments. So I think there's some positive future there. And I think this happens with a lot of things, that things kind of distribute that way. So that's like the healthcare system. And I think it's important to also call out this interesting phenomenon in longevity, which is biohacking. And you might have seen these people who, I think by definition, they're people who take some extreme measure to change their biology. So they, adopt, some of the things I talked about, and kind of that list of more untested things. They're, pioneers, I would say, trying to figure out, if there's anything valuable for them. It's all N of 1 studies though. So, that's the one issue, is that, very often they don't generalize to the general public, but for some people they can actually make pretty cool discoveries. The way I kind of think of it is, it's like the difference between airline passengers and test pilots, right? You want to, fly planes. You want to discover what is the best design for a plane. And there's some people who just have this urge to go out there and fly that plane that might explode at any moment. And I think biohackers are kind of in that category. And it allows us to, get some cool designs out and have a nice, jetliner that we can all fly as passengers. So I think it's cool that they're doing it. It's not for everyone. There's also all these fun ethical questions, fun in that, if you like philosophy and those things, like these are untested things. You don't know what the risks are. Should we let people do that? Should they have autonomy to try anything they want? These are open questions, right? There's also some legality around some of it. Some of them are controlled substances that people want to try, and they find ways around that. So there's wacky things like special economic zones in tropical places where people go, and the local governments will say, like, yeah, guys, do whatever you want, and they set up clinics there. And that is just one way to kind of make that happen. So one way or another, these things are happening, but I think it's also interesting to think about those, kind of philosophical questions. Also, we're talking about science today, so I want to call out the issues with that kind of approach is, there's no peer review, right? So there's no feedback from the scientific community about what they're doing. Maybe they comment on Twitter, but that's about it. It's also N of 1, so you're not doing any statistics between groups. There's no control, so that limits things. You do get longitudinal data, so I think that's the main strength there, but you can't make strong claims that way. Some people do, so I think there's some caution reading the results of biohacking. I think there's also like a downstream thing from that, which is this phenomenon of longevity influencers, right? So like we have social media, I guess there's an influencer for everything, and health is one of those things. And there's like people like, I'll just name off a few, like Peter Attia, David Sinclair, Andrew Huberman, Brian Johnson are all people that have podcasts, they have large Twitter followings. They communicate through channels that are conventional like books, but they also have 3-hour podcasts. If you asked me like 5 years ago if people were willing to listen to someone talk about getting morning light for 3 hours, I would be surprised, but it's true. They also do fun stuff on like YouTube, a lot of meetups, so that's another kind of interesting pattern is you can kind of go and connect with other people interested in health, which is fun. So you can ask like, well, what's the value they're providing? I would say, they're bringing science to a broad audience. Not all of them are scientific, but the ones who are at least getting people interested in reading papers and digging into that, which is cool. It also drives support for research funding. So that's a big issue in longevity is that, there's, NIA funds a lot of aging research, but they don't kind of fund as much longevity kind of life extension research. The more kind of public support there is, the better. There's also limitations, which is, that a lot of these people have financial conflicts of interest. So, they have maybe a clinic that they're running, maybe they have sponsorships, like AG1 pays them a ton of money to promote things there, I won't say who. And, so that's an issue that you can ask, are they completely unbiased in that way? So that's one factor. They also tend to, in talking to a big audience, oversimplify things, which is kind of unavoidable to some degree, but you always have to keep that in the back of your head that once you dig into these papers, there's always caveats and gotchas that are kind of lurking. I think the most fun thing that's come out of it, though, is that it's made health into a sport of sorts, so once you can measure something, humans being humans, they realize, well, I can compare myself with other people. And there's emerged this trend where people can create leaderboards and get their speed of aging done and say like, well, who's got the slowest speed of aging on Earth? And there's a leaderboard called the Rejuvenation Olympics where you can go in there and anyone can upload their results and see where you rank up. It's kind of fun. And yes, I think an example of kind of competition also driving things that people are willing to try all this stuff and in that sense. I also say it's collaborative. It's not really too vicious. I think everyone's kind of on the same team. The way I like to think of it is they've got a common enemy, which is death, so that softens things a bit. Yeah, so that's a bit about like the practice. There's like more healthcare focused things. There's kind of this N of 1 kind of world of longevity. They both coexist, I think, in this kind of fun way. You might be asking, well, this stuff is cool, hopefully. What could I do to kind of do more of it, right? There's a number of companies you can, consider working at or doing research at. Calico is one. It's a subsidiary of Google Alphabet, and they, do AI for like aging drug discovery. There's Altos Labs, which is just a unbelievably well-funded, anti-aging institute, kind of focused on cell rejuvenation, reprogramming, and just collection of really great PIs. There's In Silico Medicine, which is this wonderful international company for doing AI drug discovery, and they've got a really good track record of kind of getting things through clinical trials. So that's like big companies. There's also like small startups, so there's like Unity Biotech, which is making senescent cell targeting drugs. BioAge Labs, another kind of AI for drug discovery company. OneSkin produces the kind of consumer product, for removing senescent cells in skin. So there's kind of cool things leaking into kind of the public consciousness there. And if you don't want to go to industry, there's still academic stuff to do. So there's the Buck Institute up in Northern California, which is dedicated entirely to anti-aging research. And they do have collaborations with universities and companies, so you're not too siloed. There's like individual labs. David Sinclair is just one example who, if you want to focus on longevity, labs like that will let you do that. I think another good example is like National University of Singapore. So they've got just a large group of people who are, focused on longevity. Brian Kennedy, Andrea Meyer, and coincidentally, they have another student-run longevity club. It's the Healthy Longevity Initiative. So maybe you guys could do some sort of leaderboard between you guys. It'd be fun. Beyond that, there's like community organizations. You can kind of go to different meetups and hear scientific talks, and just socialize with people, talk about longevity. Foresight, LBF are two examples of those. There's also strange things like pop-up cities where a group of people will take over a building for 3 months and kind of live there and talk about longevity and do research and build products. So fun stuff like that popping up. Internships, SURFs, I'm sure those can be factored into longevity research too. And then lastly, if you want to get involved, just try it out yourself. Get a wearable, try out some of the stuff, that I mentioned before. It's very do-it-yourself, so so that's like a little background of longevity. I looked at it just by trying to convince you that this stuff is worth thinking about. Because I think the response a lot of people get to it is like, well, we're all going to die. Why bother? We should just live our life and be happy. Which I guess you should do that, but maybe you should, choose to not end it. I think the most reasonable argument to not do it is, well, is it even possible, right? So we're Caltech, so I dug up a story which I thought was instructive on this topic. So pardon me, I'm really going to read this because there's some quotes, but I thought it was pretty relevant. Basically, it's the history of rocketry. So rocketry is like well established today. It's kind of commonplace in the news, but it wasn't always the case. So like in the 1920s, rocketry was met with great skepticism. It's considered a waste of time by most serious scientists. One example is Robert Goddard, who he was an early visionary who, basically said that we could travel to the moon with rockets, and he kind of mapped out how that might work with physics. And the New York Times wrote an editorial, it was an anonymous editorial, and basically mocked him and said, that Professor Goddard does not know of the need to have something better than a vacuum against which to react. He only seems to lack the knowledge riddled out daily in high schools. So he basically said that it's not possible what he was going to do. And sadly, it really impacted him. It set him back. He kind of went into isolation after that. And they were wrong, ultimately, which is tragic. And later on, after I think we got to the moon, New York Times did a retraction of that, obviously too late. But I think he went out in the end. We have the NASA Goddard Space Flight Center, which is named after him. So we know he was right. So that was 1920s, and even 20 years later, it's a long time, people are still working on rockets. It was still considered science fiction. So in 1939, the US government made their first funding announcement for rocketry research, and it was for jet-assisted takeoff, just putting a jet engine on a wing of a plane and helping it take off quickly. So a Caltech team led by von Karman and a few other people, they were ready, eager to take this on. There was another person in the running. It was someone who could have done the research, but their response, was, we'll decline. You guys can have the Buck Rogers job. And if you don't know Buck Rogers, it's kind of like a science fiction comic and kids show. But like that project, ultimately went to Caltech. They succeeded. They built this. They figured out, how to build a stable, propulsion system. And I'll just note the person who declined it. It turns out they were from MIT, so I won't say anything more about that. So I think, that's one parallel, I think, with longevity is that, this connection with kind of science fiction. I think it's also interesting because rocketry kind of required this team of multi-talented people, extreme passion, kind of had to persevere over things that, set them back. So the team, who worked at Caltech was Jack Parsons, Edward Foreman, who were both people who had no formal scientific training, by the way. They were knowledgeable, and they kind of could build what they needed to build. And they complemented that with Frank Molina, who was a graduate student at Caltech. So they put together this team that really covered all the bases they needed. The one thing they needed was a faculty member, so they, shopped around and eventually convinced von Karman to join them. And I would say he didn't do much besides initially giving them lab space to work, but later on got much more involved. He actually worked out the theoretical possibility of stable propulsion systems, which was important for getting funding. So you might ask, like, is longevity impossible? Can we live forever? And whenever I think about that question, the quote that comes to mind is from David Deutsch, which is, nothing that is allowed by the laws of physics is beyond the scope of human creativity. So kind of optimistic thinking there that, there's nothing that tells us that living longer is impossible, so maybe we should keep trying. Okay, so back to the Caltech story. They had this team, and they were doing experiments in Guggenheim, and they were setting off explosions all the time. Eventually, the campus community was like, "Please leave." They didn't kick them out. They said, "Well, just set up, shop in the Arroyo." So they had some shacks where they would do their experiments out in the Arroyo. Of course, that shack turned into JPL. So yeah, yeah. And very few people could have imagined that was possible. They thought that these were some wacky guys just goofing off in the desert. So pretty amazing, I think. So I told the story because I think there's parallels between rocketry and longevity. They're both relegated to science fiction initially. They both require this passionate, multi-talented team. And maybe looking to the future, they might turn out to both have some critical breakthroughs at Caltech. So I'd like to end with a mission statement for you guys to figure that out. So thank you very much.
There will be time to ask Ryan questions right after. I want to speak particularly to our undergraduate audience who came here today. Longevity might seem like a very distant thing to think about right now, and here's my personal story and take on this. I actually landed into this field when I was 13, just by attending a conference. I was invited to present some of my research unrelated to aging at all. And the amount of opportunities that I saw from just being there and from talking to the people in this field was incredible. Now, Ryan gave us a massive summary, actually a very high quality summary of everything that happened in the last 200 years in the aging field, which was incredible. Thank you, Ryan. But we are the next generation now to make the change and to bring innovation into the field. And so I hope to invite you to our next meetings, our next talks, to really engage in discussions about things like biomarkers, wearables. What sort of biomarkers can predict how well you'll do in sport or how well you'll do in some sort of cognitive exercise, be it an exam or be it some sort of job? These things can really predict how you will perform and what you will be able to do in your future life. What if you could impact them? And that's what we want to get to in this club. So thank you so much for coming. Please, let's give another round of applause to Ryan and to his speech. Thank you. And I invite you all to try some of our Blueprint products in the back, and we have got some healthy food there as well. Thank you.